Hey there, welcome to Nandi Tech Bytes. In today's video, we will explore how to efficiently manage multiple namespaces in Amazon EKS using a single application load balancer. By the end of this video, you will understand how to set up an ALB Ingress controller to handle multiple namespaces for routing traffic smoothly. So let's get started with some brief intro to the components on which we will be working throughout the video. What is EKS? EKS is a managed service that enables you to run Kubernetes on AWS without the complexities of managing the underlying infrastructure. Next, what is an ALB? An AWS Application Load Balancer is a managed service provided by AWS to distribute incoming application traffic across multiple targets such as EC2 instances, containers, and IP addresses. It does this based on defined rules. And since it is managed by AWS, you don't have to worry about underlying infrastructure. Next important thing to understand is why to use ALB Ingress controller. The AWS ALB Ingress controller automates the setup of application load balancers for routing traffic to Kubernetes services within EKS. This simplifies traffic management by providing features like automatic scaling, SSL termination, and advancing routing capabilities, which makes it easier to manage traffic to your applications. Let me tell you the challenge we are going to resolve today. By default, if you create an ALB Ingress in 10 namespaces, then by default, AWS Load Balancer controller will create 10 ALB for each namespace, which is very costly as per ALB. It will cost you a lot. So to solve this challenge, we are going to configure a single ALB for microservices running on multiple namespaces. So this is what we are going to implement. We will have one application load balancer. Then we will be defining two ingresses. One is web ingress and web2 ingress for the namespaces, a web namespace and web2 namespace. And correspondingly, we will have services and pods for the deployments. And also we will have path-based routing. If you can see, /v1 is one path rule and /v2 will be the other one. Why to use a single ALB? As I already mentioned about the cost associated with multiple ALBs, addition to that, having a single ALB simplifies the management and also optimizes the resource usage. If you are wondering who is creating the ALB, target groups and routing rules, etc., it's the ALB Ingress controller which is deployed to EKS, and when it is triggered by an Ingress object, it does all the hard work to create ALB target groups, routing rules, etc. as per the configuration defined in the Ingress object. The prerequisites for this video are: we need an EKS cluster, then we need to set up IAM and OIDC for the controller to work with AWS APIs, then we need to install ALB Ingress controller on EKS, and then we need to create the Kubernetes objects like deployments, ingress, namespaces, and services. Let's understand the important manifests that we will be using for this implementation. Ingress class. The key purpose of the Ingress class is to define a controller that manages the routing of external HTTP and HTTPS traffic to our services within the Kubernetes cluster. In the specs section, you can see we have defined controller as ingress.k8.aws/ALB. This means that our Ingress resources will be managed by the AWS Application Load Balancer controller. Then we will be using this namespace YAML, which will create two namespaces on the cluster with name web and web2. Now this one is the important one, as this Ingress YAML file contains all the inputs based on which the ALB will be configured and used. If you notice the namespace highlighted with tick mark, it is being created on web namespace. The annotation section provides crucial configuration options for the ALB. For example, we set the alb.ingress.kubernetes.io/scheme to internet facing, which means our ALB will be accessible from the internet. Next, the listen port specifies that ALB should listen on HTTP port 80. We also define the target type as IP, which directs traffic to the IP address of the pods behind the service. The group name underlined with red is the important annotation which sets the group for our shared ALB. Other annotations can be understood based on their names itself, like health check and all. Moving to the spec section, you can see that we have referred the Ingress class that we have seen earlier. And in the rules section, you can see that we are defining path as v1, highlighted with brown line. This means when we will hit the browser with ALB DNS/v1, we should be routed to this service. Similar to the previous ingress, we will define one more ingress on the web2 namespace. And to use the same ALB for this ingress in namespace web2, we need to keep the group name similar to previous ingress highlighted with red color. If we don't use this annotation, then this ingress object will create another ALB, but that is not our goal. We want a single ALB for both the namespaces. The deployments and services for these namespaces will be created via CLI directly. You can see that on the demo. If you have not subscribed to the channel yet, then please do subscribe. Let's start with the demo now. I am using Terraform to deploy VPC, EKS, IAM, OIDC, and ALB Ingress controller. I am going to run a quick Terraform apply and approve it. I will be sharing this Terraform code with you and all the manifest file as well in the description. You can refer this and you can do an hands-on. So let's see what all are the resources that are being created. So there are total 37 resources. I won't go through all of each of them. Right, you can see most of the parts are for the VPC, and then it will be EKS and IAM roles and stuff. So I've created two folders basically. So one is 100 infra, where the VPC and EKS and load balancer, IAM, right? These stuffs will be created on inside this folder. Then you need to move it to 200 DevOps, right? That folder contains the load balancer controller driver installation, right? And for the backend, I am using S3. So if you are using this code, you need to configure your own S3 bucket and then optimize the code basically to refer your new S3 bucket for the backend, right? So if you see, by the time the EKS is created, these are all the configurations for the EKS nodes, maximum size and minimum size, right? And the tags and all. I'm not going to explain the Terraform code all through this video, just for the sake, by the time the Terraform apply runs, I'm showing you. And this is the load balancer IAM.tf, right? All the IAM policies and roles are being created. And this is the OIDC section, right? So once the EKS cluster is created, the OIDC will also be configured with the IAM role. Inside the 200 DevOps folder, you will be able to find lvc.tf, which is basically has the code like for the Kubernetes service account, right? For the AWS load balancer controller. And we are deploying the load balancer controller with Helm chart. And the provider I will be using for this is Helm provider and Kubernetes providers. Yeah, let me show you. So these are the providers that are deploying the Kubernetes and Helm objects. Okay, by now, yes, our cluster is ready, right? And the subnets and public subnets we are getting. Perfect. Let's go to DevOps folder now, DevOps tools, and I will run Terraform init, right? But before running Terraform apply, I need to set the context for the EKS cluster that we have created just now. So I'm running AWS EKS update kubeconfig command. Now my kubeconfig is updated. This path is only is been used in the provider also. So now the Terraform apply will work properly, and it's creating the resources. By the time the resources are creating, please do like, subscribe, and share your thoughts on the comment section. Okay, the resources are created successfully. Now we will go to the manifest folder, create manifest. Here all the manifest files are written. So I'm just going to type make deploy. The make file consists of all the kubectl commands. So it has deployed everything. So if you use this repository, you don't have to go and run each and every command. You just need to run the make deploy command and it will deploy everything for you. So if you see, the namespaces are already created, and this is the deployments. So in web deployment, we have one pod. In web namespace, we have one deployment, right? Let's see the service. In web namespace, we have a service also successfully created. And on the, let's see if the ingress is created successfully on the web namespace. We have this web ingress also, right? Now let's go through the next namespace, which is web 2. So I'm running kubectl get deployments -n for namespace and web 2. So this is the deployment. Next, let's see the service also. So the service is also created. And the last, the ingress resource. So if you see, the ingress is also created properly and it's showing the ALB DNS. Now let's look into the console load balancers. This is the load balancer that has been created by our ingress controller. I'm just going to grab the DNS and use that on the browser with HTTP. As I don't have any certificates configured for this ALB, and I need to use some path, V1 or V2. Let's try with V2. Okay, so we are getting 504 gateway timeout. Let's look at the load balancer and target group. What is the health check status for this? So there are 3 rules. Let me check the V2 one. And the health status is unhealthy. It's showing request timeout. So what I need to do is, I basically need to allow my worker nodes access from the load balancer, right? So I'm going to get the security group for the application load balancer. In security, so I can use any one of them. I'm taking the is 0C5 SG02VC. Okay, let me take this one. Let's copy this. Yeah, and on the EC2 instance console, let's click on instance, select one of the instances, because the same security group will be using for both the instances, and these are 2 of the worker nodes. Let me click on one of the security group to modify it. So here I need to add rules. I am allowing 8080 from my application load balancer security group, and because my application is listening on port 8080, not 80. So let's refresh this. Within some time it should come up healthy. It's taking a lot of time though for the health checkup to pass. Once the health check is passed, then only we'll be able to access the application from the application load balancer. Okay, now it's showing one healthy. Yeah, now it looks good. Let's check for this target group as well. So for both V1 and V2, we are getting healthy. Now let's hit the DNS again. So okay, Perfect. For V2, we are getting version as v2.0.0. And similarly, if we try for V1, then you should get V1 as version 1.0.1. Let me modify the path here. And if you see, yeah, it's 1.0.0 hello world. So you have successfully implemented accessing multiple namespaces, microservices, right, from a single load balancer. See you in the next video. Please do like, share, and subscribe. Thank you.